Limited, and it is originally developed by James Gosling at Sun Microsystem and released in May 1995 as a core component of this Sun Microsystems as a Java platform. So the team called Green Team, which consisting 3 members like James Gosling, Mike Sheridan and Patrick Norton, who was initiated this Java programming project, Java language project in June 1991. So initially this Java programming was designed for a small embedded systems and electronic appliances like set-top boxes. And later nowadays it can be used for many applications. So firstly it was called Green Talk by James Gosling, and the files which was created in this programming language, they given an extension as .gt, and after that it was called as Awt and was developed a part of the Green project. So actually Awt is a symbol of a strength and chosen as a national tree of many countries like USA, France, Germany and Romania, etc. So simply oak is one type of a coffee bean which was available in these countries like USA, France and Germany and all these countries. So as a history will say they are spending most of the time in lab for inventing this programming language, and they spend their time while drinking this coffee. So by that they are thinking like they have to give a program name as Awk. So later in 1995 it is renamed with Java because it was already trademarked by this Awk Technologies. So he's a person, James Gosling, so who was invented this Java programming language. So Java is both procedural and object oriented programming. So I mean that Java can support both procedural concepts like variables, uh, data types, arrays, strings. So what are the things we have in procedural oriented programming, and every concept is supported by the Java itself. And it is also support object oriented concepts like class, object, encapsulation, inheritance, polymorphism. So because of that reason Java is said to be both procedural and object oriented programming. And after this 1991 and this 1995, so after it naming as Java, so that Java is available with different versions. So it starts from JDK beta version in 1995, and later in 1996, so they made the first version of this Java programming, that is a JDK version 1.0, so which was released in January 1996. And later in 1997, in February, they released JDK 1.1, so which support inner classes, Java Beans, JDBC, and remote. In 1998, so the Java standard version 1.2 was released, which supports the strings, which is used for building a graphical APIs, and which is supported more features by this Java standard version of this 1.2. And in 2020, the new version J2SE 1.3 was released in May, so which supported directory interfaces, sounds, synthetic proxy classes. In 2002, a Java standard version 1.4 was released in February, which supports the regular expressions, XML parsers, API preferences, and which supports more secure updates. And later in 2004, J2SE 5.0 version was invented, which can support with generics and auto-boxing and variable arguments and for each loop. In 2006, Java Standard Edition with version 6 was released, which was supported JDBC connectivity. In 2011, Java Standard Edition version 7 was introduced. In 2014 March, Java Standard version with version 8 was released. In 2017, Java Standard version 9 was released in September. In 2018 March, Java Standard Edition 10 was released. In 2018 September itself, again Java Standard version 11 was released. In 2019 March, Java version 12 was released. In each and every version of Java, they are going to support a new features which are used to implement a different kind of applications like web applications, mobile applications, and networking things and different interfaces. So now they are going to added all these features, and now we are using the version is about 17 of JDK version 17. So before we are going to learn this Java programming language, we are seeing what are the terminology we are going to use with Java. So I'll start with Java virtual machine. So we can say simply Java is an object oriented programming and which is a platform independent. So when we say it's a platform independent, so we can write your program in one operating system. So which will support a platform independent. So by that, so the Java program is going to be executed in two phases. Like the first phase, you can compile the Java program and then it can generate a bytecode instead of an object code, and this bytecode can run in any other operating systems, which makes your Java is an independent platform. So there we are having a Java virtual machine, which simply we can say JVM. So like whenever the user want to write a Java programs, and that program is going to be written in 3 phases. So the programmer is going to write the program by using an IDE or any text editors, and later they are going to compile, and after that they will run the program. After writing a program is done by the Java programmer, so we are using Java C compiler, which is available with JDK for compiling the Java program. And now it takes the Java program as an input, and it generates a bytecode after it gets compilation as an output. At this running phase, now your Java virtual machine, that is of your JVM, is execute this bytecode which is generated by the compiler. So every operating system, you can take any operating systems like Windows, Linux, Windows NT, Unix, whatever the operating systems we have, and every operating system is having their different Java virtual machines. So but the output they produce after this execution of bytecode is same across all operating systems, and this will make the Java is known as a platform independent language. So simply we can say platform independent is nothing but when we return a program, and simply that program is going to run in any other operating systems without making any changes in the code. And the second is bytecode. So just now we discussed, after compilation the Java compiler is going to generate a bytecode, so which is given to your Java virtual machine, and now this bytecode will be saved in a form of .class extension. Means that .java file is taken by your Java compiler, and then this Java compiler is going to convert this .java file to .class file, and now this bytecode is given to a Java virtual machine. So bytecode is nothing but after conversion what the code we are getting from the Java compiler, so which is having an extension of .class, and the Java virtual machine code means Java virtual machine will take this bytecode and it will interpret your bytecode, and it will generate a target machine code, that is the other operating system code it is going to generate, and it will execute. And if you want to see this bytecode, then simply you can use deassembler like Java P, which is used to view the bytecode. And we are using the terminology like JDK, so which abbreviate like Java Development Kit, so which is a complete toolkit, so which includes all the compilers, Java running environments, and Java debuggers, documents. Everything is included in this JDK. So whenever you want to implement your application in Java programming language, so first of all we have to install JDK into our computer, and then you can create and compile and run your Java program. So simply we can say JDK is a complete toolkit which is used for developing your Java applications. So without JDK we cannot create or run your Java programs. And then JRE, which is a Java runtime environment. So when you install JDK, along with JDK, JRE is also installed in our computer, so which will give you a running environment for the programmer to run the Java programming. And these JRE is cannot used for compilation, but it includes an environment, so that is a browser or Java virtual machine, and it will provide a support for an applets and the plugins what you are provided in our Java programming. So everything is available with JRE. So we need not to install separately this JRE. When you are going to install JDK itself, it is going to install your JRE also. And the main thing in Java is a garbage collection. So simply we can say garbage collector. So with simply a software which is a program which is used to collect the object which are not used for a longer time in Java programming, and this will collect those objects and it can delete that objects. So for deleting or recollecting the memory, so Java virtual machine is having some program which simply we call up as a garbage collector. So whenever the programmer is going to write their code, so they have to careful about the objects. So they have been used for a longer time. So whether they are using or not, because the garbage collector will collect this references of objects and it cannot recover the memory of objects is being re-referenced. So then we have a class path. So once you install JDK into your computer, then you can use any text editors like your Notepad, Notepad++, or any other text editors we can use, Eclipse, NetBeans or everything. So then you start writing your Java program. So in order to execute your Java programs, you need to set the path. So which is said to be a class path. So because I already said after we are compiled Java program, so it is going to create a .class file, and that file is going to given for your interpreter to run the Java program. So before that, we need to set the path of the class. So that is, we can set the path like where your Java programs are saved, and we'll give that path. So the compiler will look for .class file and it will load it into Java virtual machine. So by default, your JDK will provide many libraries. So if we want to add any external libraries to our thing, it should be added to the class path. So these are the terminologies like JDK, JVM, class path, bytecode, garbage collector. So these are some terminology we are going to use with Java programming language. So we'll move on to the next topic, that is features of Java. So what are the different features we have for Java programming? So we'll discuss in brief about each and every feature which makes Java programming is very important. So nowadays you can see many technologies which are implemented using this Java concepts. So you can take any new technology, so that is going to use the concepts of this Java programming language as a basic. So now these are some features of Java programming language. So that is, Java is an object oriented and it is a portable language. It's a platform independent. Java is a secured language. It is a robust. Java is a simple programming language and which is both compiled and interpreted, and which is having a higher performance, and which supports a multi-threading, which is an architectural neutral, and which is a distributed and dynamic. So these are the features of Java. So we'll discuss about each and every feature. We'll start with an object oriented. So as I mentioned earlier, Java is an object oriented programming language which can support both procedural and object oriented concepts. So which can treat everything in Java programming language as an object. So simply we can say object will consisting some data and behavior which having some state and behavior, which supports all your OOPS concepts like class, inheritance, polymorphism, encapsulation, data hiding, abstraction. So which is going to support all these object oriented concepts, which makes your Java programming as an object oriented. And Java is a portable language. So we can say some languages portable, like we can move. Simply we can run into another platform. Then simply we can say it's a portable. So Java is a portable. So the programs which you written for Java, we can run in any other operating systems without making any modifications. So simply we can say Java is a portable language. And Java is a simple programming language because it doesn't support a complex features like pointers and operator overloading, multiple inheritance, and explicit memory allocations, and all these concepts which is supported by the previous programming languages like C and C++. So that is not at all supported by this Java programming language, which makes your Java is simple because the complexity is reduced or the complexity is eliminated from the Java developing. And then Java is a platform independent. So platform is nothing but a software or a hardware where you're going to run your application, and that is said to be a platform. And when we say the Java is a platform independent, so now you can write your code for an operating system Windows and you can run in any other operating system. Simply we can say it's a platform independent. Because when you written a program for your Windows and you can run the same program in your Linux or Unix or any other operating system, so then we can say Java is platform independent. So I already mentioned in earlier itself. So Java is having both compilation and interpretation. So after compilation, it cannot create any object file. So which can understand by the same machine. So it can create a bytecode, which is an extension of dot class, which will be loaded into a Java virtual machine, and which will interpret it, means it will convert a line by line code into a target machine code, that is the other operating system where we are going to run. So it will translate your class code into an executable code which can understand by the other operating systems like Linux, Unix, and etc. So which makes your Java is a platform independent. Then Java is a robust language, so which uses a very strong memory management. So we don't have any concept of pointers, so which leads the security issues. So we don't have the concepts in Java, so that it will avoid the security problems. And Java is having an automatic garbage collection, so which runs on your Java virtual machine. So which will take the objects which are not being used for a longer time in our Java application. And we have exception handling mechanisms and type checking mechanisms in Java. So all these things like how you are going to manage the memory and how to avoid the security issues and how to handle different types of exceptions and type checking mechanisms, and everything will make the Java is a robust programming language. And we can say Java is a architecture neutral language. So architectural neutral means we know that we are using different types of processor, like we can work with 32-bit processor or 64-bit processor or 16 or 8-bit processor. So why we can say like your Java is an architecture neutral? So there is no implementation dependent features are there. For example, you can go with the previous programming languages like C and C++. When we discuss about the data types, so every data type is having the sizes, and that sizes again depends on the type of a processor we are using. So suppose for example, if you written your programming C programming language, if you are using 32-bit processor, then you can define a data type like in integer, it will take only 2 bytes. Whereas for 64-bit processor, for taking an integer value, it requires 4 bytes. So now it's changing from machine to machine, from architecture to architecture. So those languages is having the features are different. Like for integer, for 32-bit processor, it requires only 2 bytes, whereas for 64-bit processor, it takes 4 bytes. So like that. For coming to Java programming, we can say Java is a architectural neutral. We cannot have a different sizes for different architectures. So you can take either 32-bit or 64-bit processor you can use for writing your Java program. For defining this integer data type, it can take only 4 bytes. So the changes are not required from architecture to architecture. So because of that, we can say Java is a architecture neutral. And then Java is more secured language. So because when we go with the other object oriented programming before what we have before this Java programming is your C++. So now your C++, your operating system is there, and within that operating system you have your runtime environment. So from that running environment, and you can write your C++ program, and you can execute and everything. So whereas Java, so now beside this operating system and your run environment, we have a Java virtual machine. So which makes Java is more secure, and we don't have any explicit pointers concept is there for Java programming. So because of that reason, we cannot access the memory directly. And we know that Java programs are not run in an operating system directly. So we just compile and we just load this bytecode into Java virtual machine. From that virtual machine, your Java code is going to run, and because of this reason, the Java is secured. So I will explain you how the Java is secured by using this Java virtual machine. So now we have a class loader, so which is a part of Java runtime environment. So the purpose is used to load your Java classes into Java virtual machine dynamically, so whenever it is required. And it will add the security by separating the packages for the classes of local file system from those that are imported from the network sources. So when you are importing from somewhere, now it is going to separate from the packages for all these classes of this local file system. So because it is separated from a network sources, so obviously our data is safe. And then we have a bytecode verifier in your Java virtual machine, which will check the code fragments for illegal codes. So that can violate the access rights of these objects. So when it finds any illegal code which are trying to access an objects used to interact with the classes, now it will avoid. It will check and avoid those fragments. Because of that reason, we don't have any secure issues. And we have a security manager which will determine what resources of a class can access, such as reading and writing to a local disk. So because of all these reasons, Java is more secure language, and we can say Java is a distributed So because it facilitates the users to create a distributed applications in Java programming, unlike your RMI and EJB Enterprise Java beans are used for creating these distributed applications, and these features of Java will make us begin able to access the files by simply calling the methods from any machine on the internet. So when we say some programming language is a distributed programming language, like we can share the resources through an internet. So we can share things. And then Java is a multi-threaded. So simply we can say Java, like we can take a thread as a lightweight process. So with this simply a separate program, and it will executing concurrently, and we can write the Java programs that deal with many tasks at once by defining a multiple threads in Java program. So multitasking concept is going to be achieved by this multiple threads. So these multi-threads that doesn't occupy any memory for each thread, they all can share a common memory area, and because the threads are very important for multimedia and web applications, and we can say like Java is dynamic in nature, and which is interpreted like I already said, like Java programming language is having, it can execute the things in two phases, like it can compile and later it is going to be interpreted. There will be a difference between compilation and interpretation. So whereas in compilation it will take your entire code and it can translate your source code into, in here in Java it will be converted into a byte code. It can take the entire code and it will be converted into byte code. So whereas in second phase, like after it we are getting a dot class file, after it getting loaded into a Java virtual machine. So now it is an interpreted, it will take line by line code and it is going to be translated into the machine understandable code on the other hand side. And obviously Java is a high performance language, and these features will make Java is a most important programming language in nowadays. So we'll see what are the different types of applications we can build with Java programming. So there are four types of applications, like standalone applications, web applications, enterprise applications, and mobile applications. So Java programming language is going to use to build any of these four applications. So we'll discuss in brief about each and every application with some examples. Like you can go with a standalone application, so which we can simply say like a desktop application or any window based application. Suppose if you are implemented any user interface, that is a graphical user interface for a particular application. For example, if you are created one application for your college or an organization, suppose simply attendance management system or fees management system. So those applications are implemented Java using AWT tools or swings. Simply we can use for build the interface. So the application what you are going to see as a front end, and we can set up or install that application in a computer itself or a desktop itself, and there only we can run that application. So after we are moving from that desktop or the system, we cannot run from the any other machines. So the standalone applications are built for a desktop or any window based applications, so which can run in a same machine. So if you want to run the same application in any other machine, again we have to set up the same in that machine also, then only you can see the version of that particular machine. So such type of applications in Java programming language is said to be a standalone applications. So we cannot run those applications from anywhere, we can run from that system only. Suppose see for example, by simple example I can say, like suppose in your desktop you have some application programs like your Windows Media Player or any applications you have. So that application can use for that purpose only. We cannot use for any other purposes by using the same application, and we can run in your system only. Again we want to run in any other system, again we need to install that. So such type of applications we can say as a standalone applications. Whereas the second type of Java applications are the web applications, and these applications can run on the server side and creates a dynamic pages, and that is called a web application. Like you can build one application and you can integrate this application, or you can place this application in server as a cloud area, and then you can access your web application from anywhere in the world. So once it is put on server side, so any client can access. So now these web applications are created by using Java frameworks like Struct, Springs, Hibernates and etc. And then the third type of Java applications are the enterprise applications, and these applications are distributed in nature, such as you can take like any e-commerce or any banking applications etc., or we can say like an enterprise applications, so which is created by using EJB. And the last type of an applications we can say like a web applications, a mobile applications, so which is created an application for a mobile device, and it can run on your mobiles. So such applications we can say simply an APKs, so which are going to run in your mobiles, and those things also we can implement it by using this Java programming language. So the Java programming is available with different platforms like J2SE, J2EE and J2ME. So J2SE simply we can say Java Standard Edition, and J2EE we can say it is an Enterprise Edition, and J2ME which we can say as a Mobile Edition. So I already said platform is simply is nothing but a software or hardware which provides you an environment to run your programs. So there are three types of platforms we can take, and now in updated they have other platform like Java FX, so which is going to implement your gaming applications and everything. So now we'll see the last topic in today's session, that is Java applications. Like what are the different areas we are using your Java programming language. So these are some application areas where we are going to use the Java program. So that is the desktop GUI application, simply we can say the standalone applications, right, which are going to run in your own machine. So we can use this Java programming language and we can implement such type of applications. And then we can use a mobile applications, like we can build an APKs, and which you are going to run on your mobiles. So by using this J2ME version of Java, and we can use a e-commerce and then an enterprise applications, and we can use the Java programming for scientific applications, and we are using this Java programming for web applications. Like you can use the Java programming for embedded systems. Like you can use your controllers, microcontrollers, and then you can build your embedded systems, which will be a hardware part and which is going to work for a specific purpose. And then we are using this Java application for big data technologies, and the distributed applications also we can implement using this Java programs, cloud based, web server and application server based applications, and for designing software tools like different drivers and everything, we are going to use this Java programming. At last not least, and we are using this Java programming is also for gaming applications. So now these are some areas where we are using the Java programming language to create an applications. So I hope you all can understand the basics, that is an introduction to Java programming language. So in tomorrow's session, we'll see how to install JDK and how to set a path, and there I will show you like JDK and JRE, and then we'll see the procedural oriented concepts like variables, constants and literals. So thank you so much. So if anyone is having any doubts, so you just message me in chat box so that I can able to give you the answers. So you just message me in chat box so that I can able to give you the answers. So I will share the attendance sheet in chat box. You just go through and fill the details. Thank you.